Hello everyone, welcome to my YouTube channel. This is part 6 of B Sharp in C Sharp tutorial series. In this video, we are going to learn about data types. There are two data types we are going to cover here. One is value type, another one is reference type. Later on, we are going to understand what are the default values for those data types and what are the default ranges for those data types. After that, we are going to talk about some nullable types and dynamic types. And we are going to understand all these data types with a practical example using the C# language. So let's go back to our slide. In C#, a data type specifies the type of data a variable can hold. That means whenever we are going to write a code, we need to define some variables. And for those variables, we need to use a particular data type, means what kind of data that particular variable is going to hold. If it is a kind of integer, if it is a string, float, decimal, or if it is a kind of array, list, all these are kind of data types. Okay, so whenever we define a data type using the C# language, so it indicates the type of the value, what kind of data we are going to store in that particular variable. Second one is the memory size. Based on the data type, the memory is going to be allocated. The range of the values that can be stored, means every data type would have a particular range. Within that range, it can store the value, and this range is only applicable for the value types. So there are two categories, as I told you, value type and reference type. So let's cover the value type first. Value types are those types of data type which directly holds the data value in the memory. So I hope you remember in my previous video tutorial we talked about stack and heap memory. So in that video we talked about stack, where all the value types are going to be stored. So here also it is written that value types are stored on stack. Okay, so I gave you an example in the stack. You can think like that stack is a pile of books, pile of some things. Okay, so it works on last in first out mechanism, where we use two principles. One is push, another one is pop. Push is being basically used to push the data into the stack, and pop is to read that particular data. Okay, so value types is directly going to hold the value in the memory, and all the value types are going to be stored on the stack type of memory. Okay, there are three categories under the value types. One is primitive type, second one is struct, third one is enumeration. Let's talk about the primitive type first. So in C#, primitive types are the basic data types that are predefined by the language. So they are also known as built-in types, and these types are typically used to store simple values such as boolean, byte, character, integer, decimal. All these values would be under the primitive type. There are some data types which are predefined in this C# language. So here in this table you can see the list of primitive types which are available in C# language. So I have prepared this table for you guys, where you can see the type, the description, and the range of that particular data type, and the size, how much size it is going to consume whenever you are going to use this particular type. What is the default value? If you have not assigned any value to this data type, what would be the default value for this? Okay, so all these are called primitive types. Primitive types, in other way you can say, these are the data types which are defined under a particular language. It has some ranges, it has some default value. Okay, so in terms of non-primitive type, it would not have some default value, it would not have any kind of ranges. Okay, so let's take all these data types one by one. First of all, we are going to talk about this bool. Bool is a kind of data type which supports only two range, whether it is a true or false. Okay, and if you are going to assign or define this data type in your code, it is going to take 1 bit of memory. Okay, and by default it is having a value as false. I'll give you a practical example. Let's go through this table one by one, and after that I'll show you a practical example how all these data types works. Next one is a byte. Byte data type is a 8-bit unsigned integer, where it is going to use 8 bits in the memory, and the default value for this byte data type is 0. It is a kind of integer where it can hold the value from 0 to 255. Okay, if you are very sure in your code that whatever value you are going to use, that would not exceed from 255, or it would not be less than 0. In those cases you can define byte data type and you can make use of it. Okay, after that you would be having s byte. S byte is again a 8-bit signed integer, which is going to again take 8 bits in the memory, and the default value would be 0. But here the range would be a little bit different. The range would come from -128 to 127. So now you can see the difference between byte and s byte. Byte is unsigned, which starts from 0. It would not have the negative values. Okay, but in case of s byte, you can see it is a signed integer. So in this table, wherever you see the signed and unsigned, or you can understand like this, unsigned data type would not have the negative values over there, but the signed data type, signed integer data type would have some negative values also. Okay, after this, s byte is also kind of integer which is going to hold the values in between this range -128 to 127. After that we have another data type, char. Char is basically is a short form of character. So if we are going to use if there is a like situation where we want to use a character, right, Unicode, single Unicode character, then at that time we can define this character. And if we are going to define this character over there, it is going to take 16 bits, and this is the default value of it. After that we have short. Short is a 16-bit signed integer, and it is going to take 16 bits in the memory, and the default value is 0. The range for this short is -32,768 to 32,767. Okay, it is again a kind of integer. So if you have some kind of situation where you are very sure that the values which you are going to use or you are going to assign to that particular variable would be in between these range, -32,768 to 32,767, then in that case you should use this short data type. But if you are sure that you are not going to like have the negative values over there, but the range would be from 0 to 65,535, in that case you can use this u short. It would consume the same level of memory, 16-bit, and it would have the same default value also, but the range is different. Okay, in the same manner we have this int int and uint. Integer is a 32-bit signed integer, and the range is little bit more. Okay, and it is going to consume 32-bit in the memory, and the default value is 0. Same is applicable for uint also. It is also going to consume 32-bit into the memory, but the range starts from 0 to this 4294967295. So if you sure about your ranges, how much data and how much numbers you are going to hold in your variable, so based on that you can make use of this integer data types. Okay, later on we have long. Long is again having more ranges under the integer. So long would be a kind of 64-bit signed integer where it would have the negative and positive values. It is going to consume 64 bits into the memory, and the default value of this 0. And whenever we are going to define the long, we need to put this L. We need to postfix actually this L. Okay, or we can directly assign the value. Next is ulong. Ulong is again 60-bit unsigned integer, but here negative values would not be applicable. The range would start from 0 to this big number. Okay, it is going to consume 64-bit into the memory, and the default value is 0. Next is float. Float is a kind of data type for single precision floating point number. It is going to contain 32 bits. Double is a double precision floating point number, which would hold 15 to 17 digits. Here, precision means how many numbers it is going to hold, including the values before the decimal and after the decimal point. Okay, so in total, how many digits it is going to hold. In case of float, it can be 6 to 9 digits. In case of double, it can be 15 to 17 digits. But if your calculation generates, or if you want high precision decimal number, in that case you should use decimal. For an example, for some financial kind of transactions, so at that time you should use decimal. It would have 28 to 29 digits. Okay, but you can see the memory size data type. The memory size would be 32 bits. For double, it would be 64-bit, and for decimal, it would be 128-bit. And whenever we are going to define a float variable, the default value would be 0.0f. F indicates the float. In case of double, 0.0 d. D indicates double. But here in case of decimal, the default value would be 0.0 m. So these are some default values under the primitive types. Let's go back to Visual Studio and do a practical example for all these data types. Let's start with Boolean data type here. Okay, so here I'm going to define a bool type of variable. So to define a bool type of variable, you need to use this bool keyword. Okay, here in the blue color you will see, and if you hover this bool keyword, you will see it is saying represents a boolean true or false value. Okay, so the range is true or false. And if I define, let's suppose, is active equal to false, and console dot write line, and if I'm going to print this is active. Okay, so it would just print this is active value as false, and if I assign this value as true, it would just print true here. So only these two values would be applicable for this data type. Next one is byte. So if we define a byte data type over there, so as I told you, it is going to hold the range 0 to 225. Okay, so if I define a variable a here, and I can assign a value 0 to 225. Okay, so if I assign 0 here, so it is going to print that a, it is accepting, and if I hover this, then it is showing represents an 8-bit unassigned integer. Okay, if I assign a value out of the range 256, if I assign, then you will see constant value 256 cannot be converted to a byte. If I assign 255 here, then it would accept it. And at the same time, if I assign a negative value here, -1, again it would say it cannot be converted to a byte, just due to this range. In the same manner, if I do s byte here, the s byte range is -128 to 127. So if I assign -128, it would accept it. If I do -129, so it would again say the constant value -129 cannot be converted to s byte. Okay, if I assign a positive integer here, 127, it is going to work. But if I assign more than that, it is not going to work. So every data type, this integer data type or primitive data type, would have a particular range. If you are going to assign a value out of that particular range, you are going to get an exception. Okay, next is char. So if I define a char character over there, so it represents a character as single Unicode character. Okay, so how we can define it? First of all, we need to put these commas here, and inside inside this comma, we need to write our character. Let's suppose I want to print a character R. Okay, if I do like this, it would say too many characters in character literal. Okay, character means a single character. We are trying to assign more than one character over there, then it would become an string. Okay, it would treat as a string. So we this character data type is going to hold only one character. Okay, now come to short. Short, again I told you that it is a kind of integer data type, but the range is different. So short is a 16-bit signed integer. So here you can see represents a 16-bit signed integer, and I told you signed integers means it is going to accept the negative values. Unsigned integer means it is not going to hold the negative values. So in case of short, if I put the range over there, -32 768, okay, so it is going to accept that. And if I increase the range from 68 to 69, so you will see constant value cannot be converted to a short. So everything works, all these integer is having some kind of ranges, and everything is going to work within that particular range. It is all about the memory size, how much memory size it is going to consume, and the data which you are going to assign there should be within the range of that particular integer type. Okay, so that is how you can validate all these values. So this is short. At the same time, if I use u short, so u short would be having some different ranges, which starts from 0 because it is a 16-bit unsigned integer. So if I assign -1 here, it would not accept it. Okay, so its range would be 65,535. Okay, if I do 536, it would not accept it. The same is applicable for int also. Int is going to have some different ranges. So the maximum range for this integer is 21, 47, 48, 36, 47. Okay, if I do like increase 1 here, so it is not going to accept that. In the same manner, we are having uint. Uint again is a 30-bit unsigned integer, but it is not going to accept the negative values because it is a unsigned integer. So see, next we have long. I told you that based on the requirement, based on the data range and the size, you can make use of it. Long is a signed integer, so it is going to accept the minus values, negative values, but the range would be too much high for this. Okay, I'm just writing it here. So this is the range for the long in the negative values. If I increase it, it is not going to accept it. In the same way, if I try to use a positive integer, it is not going to use. The maximum value it can hold is till 807. Okay, if I do 808 here, it is not going to accept that. At the same time, if I do ulong would be having some different ranges, but it is unsigned integer, so it is not going to accept the negative values. Okay, if I do -1, it is not going to accept that. So all these starting from byte, s byte, short, u short, int, u int, long, u long, all these are types of integer values, but the ranges are different, the memory sizes are different. Okay, so you need to make sure whenever you are going to write a code, what kind of integer data type I can make use of, so that our memory gets consumed based on our data. Okay, based on our need. The next is float. Okay, so let's come to float here. So if I'm going to define a float variable a, so you will see we can assign 0.0f here. Okay, so if I hover this float keyword, so it's saying represents a single precision floating point number. So let me give you an example in other way. Let's suppose I want to divide 1 by 3. Okay, I want to divide this 1 by 3, and let's see what would be the output. Okay, let's execute this and put a breakpoint here. Run this solution. So see how much precision value it is going to have in this variable. Okay, and later on I'll tell you how much values double is going to have and how much value a decimal can have. Okay, so a program is started, and our debugger is here, and if we press F10, and it is going to divide 1 by 3. So here you are seeing it is showing 0. Okay, why it is showing 0? Because we have not defined this value 1 as a floating integer or a floating data. Okay, so it is going to print 0 here. Now if I put, let's stop this, if I put f in front of 1, so let's see what would happen. Now see, 1f is divided by 3 and we have some floating values. Okay, so let me copy these values and put it here. Okay, so you are seeing, or maybe we can execute the last statement as well. Yes, here you can see it has returned 0.333334. Okay, how many digits are there? 1 2 3 4 5 6 7 8 9. Okay, so it contains 9 digits. So I told you that it can contain 6 to 9 digits. Okay, so after that, like when 8 digits are completed, the ninth digit, it just increased it by 1. Okay, now we are going to understand the double and decimal. So if I define a double here, the variable b, and here also again I am going to define 1 and d. If I define 1 here without this d, it is going to like return us 0 because it would treat as a normal integer, it would not treat as a double. Okay, so what we need to do is we need to put this d after this 1, and in the console.write line we need to print this, and to hold the screen we need to use console.read here. Okay, now if I define a decimal also, so that you would be having like understanding at one go about these. Okay, so now see, if I execute this program, so you will see 3 different values. Okay, for float you are getting 9 digits, for double you are getting some more digits, and for decimal you are getting some more digits. If we print this and if we go back to this, so see, so this is called precision. Precision means how many digits it is going to hold. Float is going to hold 6 to 9 digits, and double is going to hold 15 to 17 digits, and this decimal is going to hold 28 to 29 digits. Okay, so we are performing the same operation. We are dividing 1 by 3. We are doing the same operation, but we are getting some different results based on the data type. So it is all just because of the precision, how much precision values the data type is going to support. So if we have some kind of operation or some kind of requirement where we need high precision numbers in at that time we can make use of this decimal. If we need 15 to 17 digits precision number, then we can make use of this double. And if we are sure that our value would not be more than 6 to 9 digits, at that time we can make use of float. But before making a choice, you need to consider the memory size also. Float is going to take 32 bits, and double is going to take 64 bits, and decimal is going to take 128 bits, 128 bits. Okay, so this is the difference between these three. Let's move back to our slide again. So these are primitive types. I hope this is clear to everyone. Now the second value type comes as a struct. So in our recent video related to stack and heap, we covered this example. So struct is again a kind of value type that is typically used to encapsulate a small group of related data or related variables, such as presenting a point or a rectangle or some other data objects. And it is very lightweight than class. Okay, so it is going to store on a stack. Let's go back to our diagram. I'll show you by using a diagram here. So in the struct, I told you if there is a struct and this struct is having one integer value int a, and it is having one string value string b. Okay, so whenever we are going to assign the value to this particular struct, how we can assign it? First of all, we need to let's suppose the struct name is cal. So what we need to do is we need to write cal, let's suppose obj equal to new cal. Okay, and inside this we are going to assign a equal to 10 and b equal to some string, let's suppose hello. Okay, so whenever we are going to assign the values to this particular struct, okay, so it is going to be saved into the stack memory. And if we talk about the variables, so all these variables would be saved based on the data type. So this a integer variable is going to be part of the stack, and this string is going to be part of heap memory. Okay, but one location number would be saved into the stack. I have told you all about this stack and heap memory allocation in my previous video. I would strongly suggest that you please watch that video before proceeding with this video, so that you would be having a better understanding how the memory allocation works and how the data types works. Okay, so this integer value is going to be saved into the stack, and the value for this string is going to be saved into the heap, but in the stack it is going to hold the reference of that particular location. Okay, that is how this struct is going to work. So this would be saved into the uh, stack as it is a value type. Second feature from struct is there is no inheritance. So you cannot inherit the struct to another struct or to another class, but you can implement an interface into the struct. So let me give you an example. Let's go back to our Visual Studio and define a struct over here. So let's suppose it is public struct and cal. Let's name it coordinates. Okay, so inside the coordinate there is a one variable public int a, another one is public int this public string b. Okay, so that is how we have defined this struct over there. Let's define another struct called directions. Okay, so it is having two integer variables x and y. So if I want to implement this direction struct, or if I want to inherit this struct into this coordinate struct, we cannot do that. Okay, so to inherit this like any kind of class into another class or any kind of like for the inheritance, what we do is we put this symbol, this colon in front of the class and the class which or the interface which we want to implement or inherit into the this base class. Okay, so it is saying type direction in interface list is not an interface. Okay, so as I told you, struct is going to inherit the interface but not the other struct and the other classes. Okay, and as I told you, to make use of this struct, what you need to do is you need to define this struct obj equal to new struct, and here you are going to define the value for a equal to 10, b equal to some string value. Okay, and here ob dot a you can print it, and ob dot b. So in this case there is one integer and string, another one is string. So as I told you, integer is a value type and string is a reference type. So in this case, integer is going to be, this entire struct is going to be part of stack memory, and inside this struct, this integer variable is a part of stack memory, but this string would be part, the value would be saved into the heap memory, but in the stack memory it would hold a reference of that particular memory. Okay, so this is struct. Another one is enumeration. Enumeration in C# is a distinct data type that consists of set of named constant. Means if you have a kind of requirement where you are very much sure that some values are going to be a constant in your project, and those values we can reuse in our project. For an example, if you are going to maintain the status of users or user types, uh, day of the weeks, months, okay, all these are available in C# as an enumeration. You can define your custom enumeration also. Some enumerations are already available in C#. Let me give you an example how you can define the enumeration in C#. Let's go back to Visual Studio again. So to define the enumeration, what you can do is, first of all, you need to define public. You need to use enum keyword, enum, enum. Okay, and you need to, let's suppose we want to define a user type. In your application there are three types of user. One is super admin, then admin, then normal user. To define the enum, what we can do is we define user type, and after that we can put enum for the naming convention. Okay, and inside this enum is going to support the integer type, but you can define this integer type like underlying type also, means from the integer what values it is going to support. Okay, it is going to support byte, s byte, u long, long. Okay, all these things you can define. I'll tell you how. So let's suppose you are having 3 or 4 types of user: super admin, comma admin, comma normal user, some kind of thing. Or let's suppose some teacher in case of school ERP, or you have student, you have parent. Okay, so you have defined all these values. Okay, so whenever in your code you are going to save this data, you must be saving some kind of integer value, right? You are not going to save this string. So you can define this enum, write all the string values here, and you will assign a particular integer value it. If you are not going to assign, it is all going to start from 0 and gets increasing one by one. So you can see, if I hover the super admin, it is assigning 0 to it. Admin 1, normal user 2, teacher 3, student 4, like this. It in a series it would assign the value it, but you can assign the value to it by yourself also. Let's suppose for the super admin I want 001 in. Okay, for admin you want 102. Okay, so if I assign this, see, now normal user comes 103, 104, 105, 106. Okay, so that is how you can define the enum. And if I want to implement, or if I want to use this enum, what we can do is, you can see console dot write line, and if I want to print the value, or if I want to make use of this super admin value, so what we can do is we can write this user type enum dot let's suppose we want to print teacher value. Okay, so we have selected teacher, and just that's it. We need not to write again and again 104 in my entire project. I have defined once in my entire project, and we can make use of it. Okay, so if I execute this program, you will see it would print the teacher's value. So see here, it is printing teacher as a string. Okay, now if I want to print the value of this string, what we can do is we can make the conversion. Okay, and how to do the conversion? We can make use of, either we can make use of this int explicit conversion, or what we can do is, another way is convert dot to int, like this. Okay, like this we can convert this value to integer value. If I execute this program right now, it would just print the value of it. So see here, it has printed 104 two times. Okay, so that is how, using this enum, we can make use of this code in my entire project, and we need not to define these values again and again, and we need not to hard code the value in my entire solution. At one place I have defined all the values, and I can make use of it. Now the question comes, is it going to support the integer value, and based on the ranges, how it is going to work? So as I told you, here u long is going to support this much value, right? So let's take this maximum value, and if I try to assign it here, Would it work? So it is saying some kind of error. Okay, what it is saying, cannot implicitly convert ulong to int. So yeah, I told you by default enum is going to support the integer data type. If you want to configure your enum to support higher or lower integer data type, what you can do is you can explicitly inherit that particular data type. Here this is the range for ulong. Okay, so what you can do is you can define ulong here and see the error is gone from super admin. Okay, so the value is this. Now the error is coming on admin. Why it is coming on admin? Because for the ulong, the maximum value we have defined for the first variable or the first value. After that, it is not going to generate automatically. Okay, so if we provide the value within the range, so it is going to automatically assign the next values to these. So let's suppose after this 615, I'm putting 0 0 0. So see, when I decrease the range or decrease the value here, the error is automatically gone. So from here it is 000, the next would be 001, 002, 003. So that is how it is going to increase automatically. Okay, and here what we need to do, we need to do the conversion ulong. And here the convert dot to into 32, it is not going to support because it is it would be out of this range. So what you can do is, so see here in the PPT, it would be a 64-bit, right? 64-bit integer I told you. So here you need to do the conversion to int 64-bit. If I do conversion to 32-bit, it is not going to support it. It will give us an exception. So let's see in practical manner. I am doing 32-bit conversion here. Here I am putting ulong. Let's execute this. On the line number 8, it is going to throw an exception. Okay, so here it has print the value, right? And in the next line you will see one exception. Value was either too large or too small for int 32. Okay, so all these integer things works on a particular data range. So here what we need to do is we need to convert it to uint 64. Okay, so see, the conversion is done. Once we convert the value to uint 64, because it is a type of 64 and it is a uint, ulong, right? So it is going to print this value. So this is all about the enumeration. Let's get back to our slide. The next is reference type. So reference types store references to their data and are stored in the heap. So whenever we are going to assign any value to the reference type, the value would be going to saved into the heap memory, and the reference of that particular heap memory is going to be saved into the stack memory. Okay, so what are reference type? There are string is reference type, class, array, and object. If we define an string a equal to hello, this would be a reference type. Okay, and if we define a list, integer list b equal to new list. Okay, so this would be again a type of a reference type. So whenever these values are going to be part of this list, these values are going to be saved into the heap memory, and the reference of that particular memory is going to be saved into the stack. Let me give you an example using this diagram. You can go through my last video also, but here I am just quickly telling you how this is going to work. So let's suppose you have defined this list here. This is your heap memory. This is of 10 MB. Okay, and the list which you have defined, it is going to consume, let's suppose, 2 MB. Okay, so what garbage collector would do, garbage collector would assign, let's suppose here garbage collector has assigned 2 MB for this particular list. Okay, so in this 2 MB, it is going to save the actual value, obj dot the value 1,2. Okay, all these value would be saved here into the heap memory. But in the stack, In the stack, one memory location is would be allocated for the object of this list. Here it is going to hold the reference of this particular memory. Let's suppose for this particular memory, the reference number is 1001. Okay, so this number is going to be saved here, 1001. So whenever we are going to fetch the data for this particular list, what it is going to do, it is going to call the stack for this particular object, find the reference number from here, take this reference number and go to the heap memory and find the memory location for this reference number. On this memory, it would find the actual values and it would just return it to you. Okay, so that is how this entire process is going to work. Next is dynamic and nullable types. Dynamic types allows the type of a variable to be determined at the runtime. That means if I am going to define a dynamic type variable here, to define a dynamic type variable, we use dynamic keyword. And if we use a here, and if I assign a value 10 here, okay, so at the runtime, it is going to act as an integer. And if we define another variable here, this is going to act as an string at the runtime. Okay, so here we are not defining anything. We are just assigning the value to it. At the runtime, it is going to act whatever values we have assigned to this dynamic type. So this is called dynamic type. Next one is nullable types. Nullable types allow to hold the null values. Okay, how to hold the null values? .NET framework, when we were assigning a string a equal to null, we would able to do that. It is saying converting null literal or possible null values to non-nullable type. Why it is saying? The reason behind that is in .NET Core, Microsoft has made all the data types as non-nullable. You cannot, like, all the data types cannot have the null values by default. You need to make that particular data type as nullable. But in .NET framework, let's suppose here there is another project, CodeMasterBipin project. Here you would see in the properties, this is a .NET framework project, and the data types project would be a .NET Core project. So here you can see .NET 8 is written, and here .NET framework is written. So if I am assigning a string and assigning a null value to a string, it is saying converting null literal or possible null value to non-nullable type. A string is a non-nullable in .NET Core. But if I assign the same string in .NET framework, string a equal to null, so see, it is accepting the value. Okay, now the question comes, how we can like define a nullable type in .NET Core. So what you can do is, after the data type, you can put a question mark symbol over there. Once you put this question mark, that represents that this data type is a nullable type. It can accept the null values also. In case of list also, if I define a list, integer list, or let's suppose obj, okay, and if I am assigning obj equal to null, so the same thing it would tell, converting null literal possible null value to non-nullable type. Okay, if I do the same thing here in .NET framework, you would see a magic. It is allowing me to save the null values, assign the null values. So in .NET Core, what we can do is we can put a question mark after defining our data type. So now you can see, now I am able to define the null to this particular list. So these are called nullable types, and using this question mark, we can define the nullable to any data type. I hope this is clear to everyone. So in the next topic, we are going to cover about type conversion. There are two types of type conversion, implicit and explicit. We are going to learn about the variables also, how to define the variable, how we can make use of the variables with a practical example. Okay, so guys, I hope this is clear to everyone. And if you have any kind of question, you can do let me know into the comment box. I would be very much happy to answer your queries. And guys, I have a request to all of you. If you have not subscribed this channel, please subscribe it, hit the like button, and turn on the notifications so that you don't miss any kind of communication from my side or any kind of video from this channel. Please like, share, and subscribe. Thank you so much. Have a good day.